We're about to start the tour around the Arquillian universe, and I'll be your guide today. As she said, Aslak Knutsen. I'm from Red Hat. This is going to be a overview talk of what's going on in the Arquillian universe, or the community as it is. And it's not going to be a deep dive into any of the specific extensions or modules. Of course, it doesn't work when I want it to. There we go. So just to set the stage first, anyone have any specific emotions when they hear the word testing?
Love.
Love, right. What do you say?
Marriage.
Marriage, all right. Same. So, well, the general, normally people, when they are different kinds of people react differently to testing, of course. QA engineers potentially like testing. Well, developers normally tend to go with the idea that, well, my code rocks anyway, so why it would never fail. So the general consensus around testing is that it's too hard. That it's too hard, because it gets complicated to do based on your code. It executes too slow. It takes too much time to develop the tests compared to what you get back from it. And it's absolutely no fun at all. Because it's, in a lot of projects, it ends up being that last phase before you go in production that kind of never happens. That's when you're going to do the testing. And that both means writing the tests and executing the tests. And at that point, you're already 4 weeks. The deadline is already 4 weeks gone, and no one really ends up testing. But as we've been the last couple of years, the test-driven development movement, if you want to call it, has come up. And there's a different aspect to testing than to just verify the correctness of the code. And that is to enable for change. So that when you later on want to change your application or there's a new requirement, then you can actually verify that. Oh, doesn't work. You can actually verify that the application behaves the same way as it did before. We like to talk about something we call the testing gap, and that is when we are on the unit testing level. We got the single classes, we got the single methods, and so on, and everything is fairly easy to test. And most people now do some form of unit testing. But as you move out to integration, there's a whole bunch of problems that a normal unit test would never be able to catch. Specifically, things like transaction boundaries between different components. A unit test would never interact with the transaction, so you would never know if the correct exceptions actually roll back the right operations, and that your messages are delivered or go to DLQ, and all of those kinds of interesting questions. So when you move over to integration testing, you start in the Java enterprise world, you start to interact with containers. And those containers, being JBoss or Glassfish, or any of the other 400 different container types out there, you need to now start to bundle up your test cases to control their life cycle somehow. You need to control your deployment, to deploy your application, to deploy your tests. And your whole build system is set up around the idea that you're going to build the final artifact that's going to go in production. And in a larger application, that build can take a couple of minutes, or it can take an hour to actually build. So when you want to do your integration testing, you have to go away from the IDE. You have to move over to the build system and wait an hour until something happens, and potentially the next morning you will have a result. And similarly with functional as well. It just kind of the scale just continues up. It would be very nice if unit and integration testing could be executed in the same simple fashion. So within the Arquillian universe, we have three core principles. The one is that a test case should be portable between any form of container or runtimes. That runtime being something that runs your code, being a Spring container or a application server or just a JVM. And a test should be executed from both the IDE and from the build system, so that you don't have to move over into a different environment when you're inside your zone. You're sitting there hacking away, and then you have to go somewhere else to see if this works or not. It should follow the same procedure as your normal unit testing experience is. And then the third one is that we should integrate with existing frameworks that are out there. There's a whole bunch of good testing tools. Mostly the problem is that they're not integrated together, or they don't work together, or there's no coherent user experience between them. And that's kind of where the Arquillian universe comes in, to try to bring them all together and not have to reinvent the wheel. So in the core of Arquillian is Arquillian core, obviously. Take a seat. Which is built to support pretty much anything. It's not tied to any form of runtime. It's not tied to any form of container. It's not tied to any specific technology. It is built to be flexible to allow us to adapt to the new technologies that are coming tomorrow, without having to rewrite the whole shebang. And we're flexible by being extendable, meaning that anyone can hook into the same internals that Arquillian itself uses. So Arquillian core, in the inner one, doesn't do anything besides handling event executions. So basically you can fire some kind of event and someone will listen to that event, and that's the only thing it does. So within core, there's a test extension, which then builds upon the idea that there's some forms of events here, and provides SPIs for test runners and an integration with the test frameworks, test life cycles. So for instance, in JUnit, you would have the before or after class and that kind of thing, and that gets translated into the Arquillian core, so other extension then can interact with those same events. And then another core extension is the container extension, which, similar to the test extension, provides SPIs for controlling containers, being starting them, stopping them, deploying to them, undeploying from them, and generally holding their life cycles. So if we look at this setup, though it's not a requirement currently to use either Maven, Gradle, or AND plus Ivy, you could use it just off the class path. But I would strongly recommend you to use some form of dependency management system, just because while Arquillian's dependencies are somewhat complex, the container dependencies are as well, and you don't really want to handle the roughly 100, 150 dependencies that this altogether kind of pulls in. So I'm not sure if anyone are familiar with the bill of material concept. That is a POM that you can import that handles. It's a bundle POM in a sense that it will control versions of different sub-projects without you having to know which of the different versions work together and so on. So you start off with just importing the Arquillian BOM. And then you can define what kind of test integration that you want. So if you want to use the JUnit, you can say, I want the JUnit adapter. And that's the integration between Arquillian and JUnit. So if we look at the basic test class from a JUnit perspective, it's just a skeleton test, right? So you have there is a class, and there is a method that's annotated with test. And that's the most basic, simplest form of a JUnit test you can have. Then some kind of assertions. When you add Arquillian to that, Arquillian will use the run with annotation that comes with JUnit to basically tell JUnit to hand over the control from JUnit to Arquillian when it comes to executing the test. And then Arquillian adds the deployment method, or a method annotated with deployment, which is how you would define the scope or the isolation level of this specific test. In this case, we're just creating a small web archive and having that deployed to the server. And since we're talking about components and in an integration world, we're now reusing the annotations that come with the specific technology that we're integrating with. So in this case, it's the JSR 330 slash CDI annotation inject. And Arquillian will then inject back the actual instance that is running within the container, and you can continue on and assert the state of that bean as much as you want. That being a CDI bean is here, or a enterprise bean, or connection factories, or data source, or you name it. And in the deployment method, we use a API called shrink-wrap. And shrink-wrap comes in a couple of different forms. It's the shrink-wrap, the archiving, which you saw here, and then you have the shrink-wrap resolver and descriptors. So with shrink-wrap, the archive version, you can create your Java archives, your web archives, your enterprise archives, your resource adapter archives. You can create your own versions of something, your own version of them to kind of simplify or abstract away some kind of local business logic to your application. So you can imagine, for instance, having create my application with a method just says add backend, and then the implementation handles how that is actually added, or what different libraries and so on needs to be added in that case. And then the resolver is for handling the cases where you need external dependencies. So it will interact with the Maven repositories and fetch the metadata depending on what you describe here. In this case, we're loading up the versions from the POM file within the project that this is running. And we say that we want to resolve X and Y in a specific version, and then silly of me to use X and Y again, but let's say A and B in the second example, and then it will then fetch the version that is defined in your project so it will be A, B, and some version that the project is using. And that opens up for some interesting things in the case for if your application is, or if your application needs to work with both Hibernate 4 and 3, for instance, you can easily just pull in the different versions to see if it runs, or if you just need some dependencies in general. And then we have the descriptors, and descriptors is basically the same for archives, but for the content of a file. In this case, this is a web app descriptor, which has a Fluid API for creating the content of a web XML, but there's for EJB, jars, application, XML, and all the other descriptors out there. So if you're doing very specific testing, you want to test security of different filters and so on, to avoid having to write out 40 different web XML versions to the file system. You can just define them in the test and kind of do that on the run. So if we go back to look at the complete test case, in this case, there's the only thing that this describes is that there is some kind of isolation level, being the deployment method. So we are inside some kind of web archive, and we require something to handle the inject, which in our case here, we're going to use CDI. There's nothing in this case that says anything about what type of container that this is going to run on. So how is that done? Well, the container extension that we spoke about earlier has an SPI for figuring out, based on the class path, what kind of container adapter is available, and based on that, start up or boot up the container. And normally within Maven, you will create multiple different profiles to separate between JBoss, Glassfish, and so on, if you need to test between the different environments. So how does this all work? Well, as we saw, we need to select the container. Anything from a bean container being Weld or Spring, to full application servers in embedded or local modes, to the cloud. Arquillian doesn't really care. It just needs that kind of adapter to say deploy and undeploy to something. And then it will connect or start to that container depending on what type of adapter this is. Then it comes into the packaging phase, and this is where your deployment method would be called. And depending on how that is defined, Arquillian will also manipulate that same deployment to append itself, and then deploy it to the server. And in this case, or in this setting, you have access to all the resources on your client, being the file system, being class-loaded resources, classes, packages, and so on to create these deployments. And then it will run the test. In this case, we're running it in containers. So when the client test method is executed, Arquillian will basically override that execution and move and or use the Arquillian protocol to then evoke the test inside the container. And when that test method is executed, you have access to inject or look up any form of resources that will be available within the container. So you can inject the connection factory and send messages. You can inject a user transaction, start and stop, or rollback transactions. You can inject EGBs. You can inject data sources. Just the same as your normal application would. And then it will capture the result based on your assertions, and then move that back to the client side. Based on the test framework integration, it will add all the test results in the normal fashion. So you will see the green bars in the IDE, or you will have the Maven Surefire reports. So it can run just as well from the IDE, from Jenkins. And then it's an undeploy and disconnect. So that's the basic of what Arquillian core does. Any questions so far? Just put up a hand and ask if there's anything.
Does it really work?
What?
Does it really work?
Well, we'll see soon. We'll see. See if it works. So, we're going to have a demo. We're going to show a couple of different extensions. With the persistence extension, drone, warp, and graphene. Hopefully you'll know what that is afterwards. Let's see, swap over here. Keep this. That one. Can everyone see this okay, or should I up the resolution? Or up the font size, rather? Everyone? Good. So first we're going to see what core Arquillian core provides. So this is a test case, as we saw before. We are using the run. Oops. We are using the run with annotation to define that we're going to use Arquillian. We have our deployment method. We have wrapped that up in a factory type pattern just to avoid having the whole definition in the test case itself. But it doesn't do anything more interesting than creating a Java archive, adding some classes, and adding beans XML and persistence XML. And then when this test now executes within this server, we're starting to inject things like the EGB and the user transaction. One step back and just see what our application does here. It's a fairly simple little thing. So we have our simple JPA entity model that is it's a conference, and it has multiple users. So fairly simple, and it needs a repository to which is a stateless EGB, which interacts with the entity manager, just to store, get, and list. And then we have a REST interface, and then we have a JSF bean, or it's a CDI bean, but for the view layer, which is JSF. Nothing too complicated. So for the core test, so this is now defined to be a in-container test. We want to inject the conference repository. We want to inject the user transaction, and what we want to check is that if we store a conference in one transaction and try to read it back out again in a different transaction, that actually those values were stored. So we have just created a tiny little wrapper method here that handles a callable. So begin transaction before, call the callable and commit. And the other ones are just basically calls repository store and repository get. So now, if we start up an application server here in the background, oops, that's AS7, and we can just do right-click, run as JUnit test. So we should see it starting to deploy our application or our test application. We'll find the EJBs, bind them up. It will start up Hibernate. It will start up CDI. We'll add stuff to the database, and you'll see it doing the insert statements, and as if the normal application was running. So if we connect with the debugger here to the app server, just to verify that we're actually in the container, I can set a little breakpoint here, and we run. There we go. So now we're inside the test method, and if you look, it's probably a bit hard to see. It's a bit small, that font there, but you will see it coming in through the HTTP request on the server, and it's not in the IDE thread instead. So that's one side of core, that being the in-container version of it. But we also had a REST API here, and similar, we have the run with annotation, the deployment, but in this case we're going to say testable false. Very poorly named API, but anyway, it means basically that you're not going to prepare this deployment for being for supporting in-container testing. So the only thing Arquillian does is to deploy what you actually define there, instead of the other one where it adds itself and does a couple of other things. So in this case, the test method will actually run on the client side and not in the container. And one of the nifty things here is that since Arquillian controls the container and controls the deployment, it also knows what's being deployed. So it can give you things like it can inject the URL to the web context where this application is running, as opposed to having to separate them out into different properties files for different environments. So you can move between the staging, test, and local without having to really consider where the application is being deployed. And in this case, we're just using the HTTP URL connector to do a post to insert some data through the REST API, and then doing a get to get that data again, to validate that that's the same data. And it's not very much more complicated than that. So again, if we just do a run as JUnit test, you should see it deploy. Oops, there we go. And it's done. All right. And we have a green bar. Awesome. So just to prove the point here again, if anyone can see, will be that when we debug this, we are now actually on the client side instead, which is coming in through the remote JUnit integration in Eclipse. So that's the two operation modes within Arquillian core itself. It's the in-container and the client side, and doing the injection of the different technologies, being CDI or EJBs. So, what we had the point of this talk was to show what's in the Arquillian universe. So if we look at this repository test again, or this entity model test again, it's fairly duplicate data where we're checking every value. And if you consider having a large data set, you probably have some loops to test the data, and it becomes quite repetitive code. And that's where the persistence extension helps. So if you got data-driven tests, you might consider looking at this. The only difference is that we are now annotating up a couple of more annotations on the test method. One they called should match data set and a cleanup strategy. So based on our definition here, we're saying that there is a data set called conference with speakers. Let me find it. Conference with speaker. In this case, which is a YAML file, it's a bit small and hard to see. Let's just search. But basically a YAML representation of the data and the tables that should be there. This also supports XML and Excel and JSON and whatnot. Underneath the hood, there is this is based on the dbutil library. So in our test case here, we are saying that we want to still inject the EGB conference repository, but when we are done executing this test method, which is storing something in the repository, we want the persistent extension to validate that the data in the database should match this data set, but exclude ID and conference ID and speaker ID, because those are dynamic values. And when we're done with the validation, clean up and remove the data that we inserted. And in the next test, we're using the same data set, but now we're saying that before you start executing our test, and use this data set, basically insert all this data, and then we can just do the repository get some conference instead and validate that our logic does what it's supposed to do. So we can run that as well. And again, green bar. So does it work? Yeah, it does work. You see? So yeah, for functional testing, there's drone, which is an extension to basically help with the management of the life cycles of things like Selenium or the web drivers, and instantiate them, potentially start the Selenium server for the Selenium 1 APIs. And again, nothing more specific here, except that we're injecting the URL to the base URL to the deployment that we just did. We still want to test this on the client side, since this is a Selenium-driven one. And then we just do the standard driver get find by ID. And basically we have a JSF form that we want to input some data and submit it. So in this case, the drone extension, when we run it, will start up the there we go. Let's put a breakpoint there instead. We'll start up the browser and execute it as if it were a normal Selenium one. And that gives you, when you combine that with the IDE experience, you can, like this, set a breakpoint, and you can then go further into your application and start to set breakpoints on the Java code as well. No, the JavaScript code, and then you can kind of combine both as two IDEs, and it's kind of interesting to do that kind of debugging. But that's more of the browser than drone. Let's continue that one, and it's done. And similarly, you can of course connect drone to say that you're not going to use a local Chrome, in this case, driver, but you're going to connect it to a Selenium server somewhere, and then we just forward a request to that Selenium server, and the execution happens there. In case you're on a Linux box and you want to test a Internet Explorer version, for instance. And then there is warp, and warp is a kind of cool little extension. So while Arquillian core can either execute on the client side or in a container within one test method, you can though mix them so you can have multiple test methods within a test class that either run on client or in the server. Warp kind of combines that into one experience. So what it does is when we're going down here, we again just gonna navigate to the by still using drone to inject the driver and we inject the URL. We are navigating to the JSF page, inserting all the data in the form. But when we're going to do the click or the save submit action, we wrap that execution into a client action, which is the warp. Bring that up a little bit, which is the warp feature. And then we say when that action happens, we're going to verify that our other server assertion here actually happens. So the warp will stack up the server assertions on the client side. So when the client HTTP request comes, it will piggyback that server-side object onto that request, move it to the server, and within the same life cycle, it will then execute that server assertion. So it's not an either/or, but you can verify or manipulate the state within the same request that you are doing. So in this case, we have the verify conference. So when the JSP page the JSF page is done, meaning the after servlet phase, we're going to inject the conference repository and verify that this is actually stored. In a case where, for instance, that you're inputting something to a form and that it's showing on the web page doesn't necessarily mean that it actually went to the database. So here we're verifying that when the web page is done, we're trying to fetch it out from the repository and see if it exists. So the interesting thing here is that you can serialize objects from the client side to the container as well. So we're creating a conference object on the client side, which is our JPI entity. We are using its values to put in the form, and then we are sending that object to the server. And when the HTTP request is done, we're verifying that what's found in the conference repository on that conference's ID actually matches the values. And similarly, you can transfer objects back from the server from that specific life cycle as well. If you need, for instance, to something happening on the server side needs to, or based on information that's happening on the server side, you need to do some extra action on the client side. For instance, to find the ID of something that was stored. So let's go through this one more time. Set a breakpoint there, and we set a breakpoint there, and breakpoint here, and we run it. And this works with any, it's not bound to drone at all. It's any HTTP request. So you can use the URL connection. You can use anything that basically creates a URL. Or interacts with the HTTP URL. So now we're inside the warp execution on the client. And if we're looking at the stack trace here again, or the stack, we are within the remote test runner from Eclipse. And next one is inside the server assertion, and we should be within the HTTP request on the server. And where do we go? And at this point, of course, we have the the manager, the conference repository here is actually a CDI proxied bean, which refers to a EJB in the background. And here as well, you can inject your queues, your CDI, EGBs, your whatever you have access to. Security, for instance, if you want to set up before a servlet executes, you want to set up a security context, and then you can destroy it again after. Similarly, we also support in that in the server assertion the JSF life cycles, so you can intercept different before render, after render, etc., and do or verify the state. So manipulate or verify the state. So that was warp. Graphene. We all saw these horrible selenium things, which is why selenium or a lot of people don't like selenium, specifically because of the selenium IDE that generates up this insane amounts of actions. And if you just dump those into a script, anything you do to your application later on will basically break every test case you have. So the Selenium guys came up with the concept of a page object, which is basically to wrap some of these find by ID or CSS rules and so on into a more consumable Java API, so that the test case doesn't have, or all the test cases don't have to worry about repeating this type of code, but you can change it in one location instead. So Graphene is a Selenium driver wrapper that basically it helps you with a lot of the AJAX wait operations and a lot of those types of actions, but it also brings the page object concept to page components. So you can have reusable web components within your page. So you inject a page, and you can further on inject the actual component, which then has the defined by annotations on it, and you end up with a Java API to kind of move and set the values and get them and do the navigation and so on. And it's one thing that you have your own, or that you can create your own, but libraries like Rich Faces, for instance, in their next version will come with a set of test components for all of their components, so you can just inject them, or you can just reuse their test artifacts and inject within your page, for instance, a autocomplete element or a task list and so on, and just reuse the Java API without having to worry about the actual HTML that someone else's component is producing. So as we did in the other one, we're basically just creating the model on the client side and setting it through this API. So we have a page object, we get the form, we set all the values, and then execute the form submit within the same type of client server assertion actions. If we run those again, it doesn't do very much beyond. Oh, it's done. Oh, look at that. Am I stuck in a debug mode there? Oops. That's not supposed to happen. Let's try that again. It's more happy. There we go. It's just hanging the opposite, the other JUnit process from earlier that was hanging. That's confused it. Oh. Do it again just to verify. Yeah, green bar. That was basically some of the extensions that exist within the the Arquillian universe. Any questions? Any comments? Any thoughts? Any?
Is it working also with TestNG or only with GPU?
No, it works with TestNG, with Spock, with we're working on JBehave. Cucumber has an integration. Yeah, a bunch of different versions for it. If we go back to this one, so that was the demo. And why do we call it a universe? Because of course there's a whole lot more than just those 4 extensions. For the web and Java EE type, there's all of those different extensions to handle different aspects and to integrate with different other test frameworks. So we saw warp, drone, graphene, persistence. There's a transaction extension to help with creating, stopping transactions, like having a transaction boundary around a test case automatically set up or rollback on test end. JSF Unit 2, Theme 2, and Portal and REST extensions to kind of work with those frameworks. There is a mobile side, can set up the Android or iOS emulators or connect to a running device. Currently, by only executing the WebDriver integration for them, but there's work being done on having what's it called, Robotium or similar. Robotium? Yeah, something like that. Which is basically similar to what Arquillian does with these APIs, but you kind of get it inside the container, and then you can kind of invoke more of a user interface API on the actual application itself instead of having to just do the web browser. And there's a whole bunch of tooling coming out. There's a Maven plugin for handling just the container start and stop, kind of similar to the Jetty Run plugin that will deploy the artifact that is being created by the module you're in. There's Forge plugin to help with the setup of the project, adding dependencies, finding out which versions exist, and all that. JBoss tools have now started their integration. So on your deployment methods, for instance, you will have, if you're referring to classes that are not in your test class that are not in the deployment, it will give you an error. If you're referring to class loader resources or files within the deployment, it will add a pointer so you can just click and kind of go to the file. Special integration for running Arquillian tests, not that you need it, but it will simplify it with a right-click, run as Arquillian on a specific container, as opposed to having to swap the Maven profiles in the background instead. Give you a view of what the content of the deployment is. JRebel integration to speed up the deployment, of course, when you're doing the development, when you're re-executing the same deployment or the same test case over and over. The JRebel integration works the same as how JRebel would work. So basically, you just deploy it once, and then you let JRebel handle handle the updating of the classes and such. Jakuku to do code coverage in remote servers, and we'll pull back the results without you having to actually do anything with the server itself. And there's Byteman integration, if anyone knows that project, to manipulate your code runtime, so you can say annotation on the method that the class, a specific class or a specific method, when that executes, you want to do something else than what it originally intended to do. So you can force exception cases. You can, for instance, have 2 different servers that are running in a cluster, and you can on one of them say that the Java stack is not going to work anymore on that one, and how does that affect the replication between the nodes? Rush for doing visual testing. Is this blue box actually blue, or is it in the same location between the different browsers? A little performance one, and then we have all the test runners. Then we have all the containers, which is a whole bunch of them, in all in different versions as well. So JBoss has 4, 5, 6, and 7. Glassfish only 3. WebLogic has a couple of versions, etc., etc. So anyway, what Arquillian is trying to do is to create a community around testing. Our focus so far has been more on the integration testing and for the enterprise containers, just because that's basically been the biggest gap. There's really never been a proper testing tools for it. But we're expanding in the sense that we're going to mobile, we're going to cloud, we're going to anything from middleware down to the OS level, basically. And trying to build a community which the main focus is around testing. And so if anyone want to get involved in that, we're not just looking for developers, we're looking for testers, we're looking for writers, we're looking for artists to do the design of logos, etc., content, publishers, you name it. We're welcoming everyone, basically. So we have the Google Plus page, which is where you find a lot of the more release information, blog posts, things that are happening. Arquillian.org, the main site, has guides for getting started on a lot of them, a lot of the information about which extensions exist. We're of course on GitHub, which you can find all the source, even the source for the website itself. And a lot of us are hanging out in the JBoss testing on Freenode if you want to drop by for a chat. Thank you.